Okay, ladies and gentlemen, good morning. The time is now 10 o'clock and the inquiry is resumed. Today is day 5 and for anyone new to the inquiry, my name is Helen Heward and I'm the Planning Inspector appointed by the Secretary of State to hold this inquiry into the appeal by Clearstone Energy Limited under Section 78 of the Town and Country Planning Act 1990 against the decision of East Devon District Council to refuse planning permission for a proposed development described as the construction, operation and maintenance of a battery energy storage system with associated infrastructure and works, including highway access, landscaping and biodiversity enhancements, at land just south of Hazelhurst, Raymond's Hill, Axminster, Devon. Okay, so the usual reminders, please to put all of your devices to silent for the duration of the inquiry, please. Like other days, we're going to aim for a break around about 1 o'clock, but it will be very much be guided by how we go with the evidence. We aren't expecting a fire alarm today. It'll be tomorrow. Again, we'll have one at 10 a.m. So today, if the alarm sounds, just a reminder, we leave through the doors at the back, we go down the stairs, the lift's out of order anyway, and we meet in the car park outside. Okay, so today we're going to be looking at evidence to do with emissions. Before we get to the witnesses, just a couple of housekeeping matters I think we need to deal with. Yesterday I undertook an accompanied site visit and I was accompanied by Mr. Digby for the council, Mr. Myers for the appellant and Mr. Lever for the Rule 6 party. They accompanied me on most of the visit and I looked at the outlier points on my own. I was provided with a most excellent picture and also written words as well, so I couldn't go wrong. But on the site visit, it was explained to me that there were a few last-minute requests from the Rule 6 party. So I think someone was going to give me an updated record for me so that we've got a record of everything, where we went and what we did.
Yes, Madam. Mr. Myers is sending that through this morning. So he was travelling back yesterday, but he's on it this morning. We'll send it through.
Okay, lovely. Okay, so that deals with that. Yesterday, I also understand that there's been some correspondence regarding late evidence in relation to the witnesses that we have today, but I haven't had an opportunity to read what was sent in. So perhaps if I can ask Miss Osman-Smith to explain.
Yes, Madam, of course. There's essentially 3 documents. The first is a technical note from Mr. Fellows, which concerns an error that was made in the calculation in his proof, or rather the figure that was inserted. It's a typo from paragraph 3.6.8, and then the measurements have been clarified for Appendix C. The thought behind distributing this now is so that he doesn't say this for the first time in his evidence. So that would have been a factual correction that he would have made in his evidence. And obviously at that point, it doesn't give anyone time, and you might turn around to us and say, well, actually, can I have a note with those figures, because they're not anywhere else. So that was the thinking behind providing that now. So I've got a copy of that for you, and of course, members of the public. The other 2 notes that we have I've discussed these with my learned friend. I understand that he doesn't object to those going in, or the note from Mr. Fellows, although I think there's a caveat about Mr. Carpenter having an opportunity to look at that and just respond to the points that have been made. On the two notes from Mr. Lester, the first concerns PFAS from cars on the B3165, and what Mr. Lester did was look at the traffic counts to come up with an estimate of what the PFAS deposition is likely to be from that source close to the site. So he's provided some paragraphs on that and the supporting information which comes from the DFT traffic count website. So that's usefully a single page. The next is in terms of the DMV plume assessment. So when Mr. Lester came round to his detailed preparation in advance of giving his evidence, you'll recall from his proof that he had understood that the gas measurements used were the highest 1 minute concentrations. He sets that out in his evidence. On reviewing the data set that sits behind that, they're actually the highest 5-second data points that have been taken. So this clarifies his understanding of that and summarises what that means for his evidence. Now, unfortunately, the data that sits behind that is rather more voluminous, but we've provided that so that Mr. Laxon had an opportunity to take a look at that, and we've got copies of that for you, although I suspect that we won't have to delve into that spreadsheet.
Mr. Parkinson.
Thank you, Madam. Yeah, Ms. Osman-Smith's right. We don't object to any of these documents going in, but if I could just briefly talk to them. The technical note from Mr. Fellows, that's fine. The only slight caveat there is I haven't had an opportunity to speak to Mr. Carpenter about it, and I think the calculation in the note differs slightly from that in the appendix. Now, it may well be that I speak to Mr. Carpenter and he says that's absolutely fine, but I don't know yet. So all I would like to do is just reserve an opportunity to, if there is something more that sits behind it, for Mr. Carpenter to put in something in response. But if that is going to happen, it will happen today, so that Mr. Fellows has it before he gives his evidence.
Okay, very good. And that's on the first document, and otherwise with documents 2 and 3, you're content?
Yes, documents 2 and 3, we're content to go in. I mean, I do need to note that the PFAS note is entirely new evidence. It's not in response to anything because Mr. Laxon didn't put in a rebuttal. But having moaned and said that, we've had an opportunity to consider it, so we're fine for it to go in.
Okay, very good. Do you want to hand up copies then, please, Miss Osman-Smith? Thank you. Mr. Parkinson, please keep an eye on making sure that you've come back to me about Mr. Carpenter, in case I get distracted, and thank you. Just whilst Miss Osman-Smith is arranging copies of those for everyone, are there any other housekeeping matters? Mr. Parkinson?
Madam, there's one. If you recall, on Friday afternoon, the hydrology experts undertook to provide an agreed note. As I understand it, that isn't ready yet. There is a note in circulation, but it's not yet reached final form. So hopefully we can update you on that by the end of the day.
Thank you very much.
That's my understanding too, Madam. They're talking, so that's useful. Are we able to number these now? Because what I'll do is I'll put the inquiry document numbers on them and I'll make sure they get to the back of the room for anyone who wants to see them while we're discussing the evidence.
Excellent.
I'm looking around to someone who's looking after the inquiry documents and knows what number we're up to.
I'm not sure, but all I would add is we also didn't give an inquiry number to this, so whatever number we're up to, we also need to add this to it. It should be on the website, because I think the website numbers it.
I think CD 18 or 8 is the last one.
Those are core documents rather than
It's ID 8. It's the last one.
And was that the drainage calculations at ID8, or does that need to be ID9? Sorry, that was a statement of...
Sorry.
So does that make the table from Friday ID 13?
So then if we say Mr. Fellowes' note is ID 14, then we'll go for PFAS from cars as ID 15A for the note and 15B for the data. And then the second note will be ID, again, 16A and 16B. Thank you.
Could I have a printout of where we're at with the inquiry documents? I think it'd be useful for me to have it on the table. Thank you. Okay. Just looking to the back of the room now, if I could just ask if there are any interested parties who would like to address the inquiry at all. No, no nods there. Okay, thank you very much. Right then, if that's all of our housekeeping, let's get on with our first witness, please. And yes, it's Mr. Parkinson this morning, isn't it? He's...
Thank you, Madam. We have Mr. Laxon with us. I'll just ask him to read out the oath first before getting into the evidence. Mr. Laxon, you should have that on the table. Yeah.
Yep. I do solemnly, sincerely, and truly declare and affirm that the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
Thank you.
And then in terms of the documents, obviously Mr. Laxon's proof, but then in addition, in terms of proofs, Mr. Lester's proof and rebuttal, and then potentially the proofs of Mr. Blunden, Reynolds and Fellows. And then in terms of CD references, the plume assessment, which is CD 1.31, CD 8.3, which relates to PFAS. We're going to go into CD 9.2, and I think where we're going is the CSA test documents. So it's CD 9.2C. And then finally CD 15.6 and 15.7. Thank you. So with that by way of introduction, Mr. Laxon, I'll just introduce you by reference to it's section 2 of your proof. And we can see there that you're the founder of Calico, an environmental consultancy specialised in air quality and other matters. You have a first-class engineering degree from the University of Warwick, and you're a full member of both the Institute of Air Quality Management and the Institution of Environmental Sciences. You have nearly 20 years' experience of air quality, and during this time you've worked on hundreds of air quality assessments, including for various port schemes, road schemes, residential, industrial processes, energy from waste sites and infrastructure projects. And we can see also that you're vice chair of the IAQM and are leading the IAQM professional guidance documents on dispersion modelling, greenhouse gas assessment and air quality assessment for planning. Is that all correct? Brilliant. So as with other witnesses, we'll take your written evidence as read, and then I'm going to just ask you some follow-up questions, and we're going to do them by topic. So the first topic is a sort of gentle introduction to all of this. Can you just start off by dealing with what's likely to be in the plume that we've heard discussed earlier in the inquiry, just in general terms to start?
Yep, sure. I understand that last sessions you would have discussed thermal runaway. It's not going to go into any detail about that, but during a thermal runaway, the event will cause an off gas, which will have toxic pollutants in it, in the absence of a flame. But when a flame occurs, there will also be additional pollutants. The pollutants are set out in my 7.17 paragraph. I consider there to be a number of gaseous pollutants, including hydrogen fluoride, carbon monoxide, and a series of others. I also consider there to be emissions of particulate matter, or soot. There will be emissions of hydrocarbons and volatile organics. There'll also be emissions of PFAS and metals. If you look at my 7.2, I refer to the metals for the type of battery technology as being copper, iron, and aluminium. So these are the types of pollutants that will be in the plume when it's under fire, and a series of them will also be in the plume if there's no fire as well. So
Thank you. Now, there's in various places in the evidence disputes about the emission measurements which have been used here and then inputted into the plume assessment. Can you just talk us through what the issues are in dispute and what your evidence is in relation to that topic?
I must just first of all start by saying that where I'm going to start is focusing on just an example pollutant of HF, so hydrogen fluoride. The reason for that is there's various evidence and it's a significant emitter. What I want to do is bring your attention to my paragraphs 7.26. And this is where I have reviewed. And 7.26, I refer to various different literature reviews of emissions of hydrogen fluoride, which is one of the pollutants. There are others obviously as well. Being in the range in the first bullet point of between 20 milligrams per watt hour and 200 milligrams per watt hour. This is relevant because this is being referred to in Mr. Blunden's evidence as well as a reasonable range. It's also useful just to contextualize that in terms of what the emission measurements represent. And I acknowledge that the large fire study actually measured emissions, And my evidence on, if I switch to paragraph 7.27, I've calculated that the emissions that are measured equate to about a range of between 33 and 49 milligrams per watt hour. So this is showing that the emission measurements were in the lower range of studies that show it's between 20 and 200. So it's reasonable that the emission measurements demonstrate that it's in that range. I, however, have concerns about the actual emission measurements and how it is conducted. If I can take us to the, just not the best way of doing this. If we can switch to Mr. Lester's proof of evidence, which is CD 6.5. And if we can refer to figure 1, which is on page 8. This is a graph which shows measurements from the fire test, where the sensor is located above the plume and above the fire. So it's, just to confirm, the sensor that measured these concentrations is located above the center of the central container, central unit, represented by the red dots in the top and the left-hand, top left-hand corner, and the figure represented there. The sensor is probably about 0.7 of a meter above the container. The reason I say probably is it's estimated it's about 7 foot above the center line of the container, and I've judged the container to be 2.7 meters high, and therefore I calculate it to be between 0.7 and 0.8 of a meter above the center point of the container. So this is where the sensor for measuring the concentrations is located. The blue line on the graph shows the HF concentrations measured. And this measurement's in ambient conditions, so it's outside. It's above the container. And the challenge with measuring such emissions, and when they're above the container, is that the plume from the smoke moves, that you have a point sample location, and that there will be occurrences when the plume is not going over the sensor. This is important because a lot of the reliance on this data considers the peak emissions. And the data that we've been provided with this morning, or yesterday and this morning, averages peak emissions of 5 seconds over a longer period. And my concern with doing so is that the troughs, which is the lower parts of the graph, are not necessarily occurrences when there's no emissions, but when the plume does not encounter the actual sensor. So if we're averaging data, then including the troughs here can misrepresent the actual concentrations. It's just demonstrating a potential occurrence when the plume, the smoke plume, is not going over where the sensor is. An analogy would be I don't smoke, but trying to light a cigarette in a windy conditions. If the flame from the lighter is not constantly in the same place, then you won't get sufficient heat, and it won't light a cigarette. In the same way, if the plume's moving, and it will be from this type of fire, then you won't necessarily get emissions at that location because you're sampling at a point location. So it's important to recognise that any process of averaging doesn't necessarily represent the actual emissions. The process of averaging might be averaging occurrences when the plume is not in contact with the sensor. My other concern with reliance entirely on the measurements is the duration of which the measurements were taken. So if I can refer back to my core documents, sorry, my evidence, which is core document 13.1, and take us to figure 5, which is on page 13.
Figure 5, good proof.
Of my proof, yes. Apologies. So figure 5 shows an extract from the fire test that was carried out, and it shows the timing events for when the measurements were taken. The important thing here is to understand that it was intentionally triggered, so the fire was started intentionally, and there was a time before required to get a sustained ignition of the batteries, so thermal runaway, and that didn't start at time 0. If you're looking at the second column, that started after 34 minutes. So from 34 minutes onwards is when we're starting to look at emissions that are relevant to thermal runaway. Due to issues with the actual fire test, the sensor, which referred to here is the FTIR, it was removed from the plume after 1 hour and 11 minutes. So we have a very short window between when emissions were occurring and when the sensor was moved. So it was moved out of the plume entirely. So any data after that point doesn't represent the plume, and we only have a short window of approximately 37 minutes. So 37 minutes is the 1 hour and 11 minus approximately 34 minutes from start time. So we have 37 minutes of measurements, and it's my belief that there would be significant emissions after that window occurred, and that is evidenced with further descriptions in the table which talks about the fire intensity increasing, so approximately 6 hours, 14 minutes, based on a visual analysis. Also, if I can further that point and take you to the plume assessment, which is CD 131. And page 7 of the PDF, or figure 3-3. Sorry, it's page 6 of the document, or 7 of the PDF. And figure 3-3 is the DMV who carried out the plume assessments, example of how escalation from module to module would occur within a thermal runaway in terms of the emissions of the off-gas. So this is explaining that during thermal runaway there's propagation from cell to cell, and that from module to module and so forth and rack to rack, and that you'll get an ever-changing amount of the fuel, the off-gas, occurring, and it depends on how many cells are experiencing thermal runaway at that time. The figure effectively shows that after about 45 minutes, that's when the peak release rates would be sort of expected to start to occur, and they can go on for another 2 hours looking at this. So it's 165 minutes minus 45 minutes, which is the x-axis on the graph. So that during that time, there'll be lots of cells emitting, and that's when there'll be a large period of emissions occurring. So we've got the fire analysis, which suggests that, which stopped measuring after 37 minutes, but we're also aware that it's likely that the peak emissions will start to occur in terms of the off gas and the corresponding emissions after 45 minutes up to 2 hours. So we don't know from the emissions testing whether the peak concentration was measured or not, knowing that it was moved after 37 minutes from a sustained thermal runaway. So I have concerns that the relying exclusively on the emissions testing to provide the data is not going to provide worst case, and it's not robust. And I would say that a lot of the assessment is based on the use of that. In terms of the data that's been presented today, so if I can, I appreciate we said we weren't going to go into any detail about the spreadsheet, but I just wanted to pick up on a couple of points on that data. So this is ID 16B, which I think is a paper copies for most. So this is the 5-second data from the measurements, which, as I've explained, only go up to the point where before it's moved, or it's only relevant for the point before the census moved. This process has been to average emissions, and just purely one point that I don't know how it's presented on the printout, so I apologise. But there's a column which averages 10-minute HF, which is hydrogen fluoride, which on an Excel spreadsheet is column Y. I don't know if that's on this data or not. So, that provides a 10-minute average, and I just wanted to point out that average has been presented as occurring at set intervals, so every 10 minutes. But actually, it should be a rolling average, so it should be calculated for every 5-second period. And I very quickly this morning looked, and that by doing so, you actually get a higher ratio. So the evidence presented in the note related to this, which is ID 16A, in terms of percentages, is currently incorrect.
Sorry, can you just talk us through that again? Just explain why it should be a rolling average, just that step in the reasoning.
Apologies, yeah. So when assessments are carried out considering a 10-minute exposure, so in terms of ambient concentrations, that's not fixed with people being exposed for one 10-minute period, then the next, and there's no overlap. Actually, it's relevant that any 10-minute period is the relevant exposure. So by not doing a rolling average, which assesses the continuous 10-minute period, you're missing the actual true 10-minute average for relevant exposure. So it is essential to consider a rolling average.
Thank you. So the point about rolling averages, and you say that affects the figures in Table 1 on ID 16A, is that correct?
That is correct. And my other concern as I expressed earlier, with regards to this data and the approach of averaging is with a turbulent flame, a flame that moves around, which is what occurs with a fire. As I've said, there's a extremely high probability that the plume will not always be in contact with the sensor. So these troughs, the lower measurements, don't necessarily represent a lack of emissions. They represent a lack of the flame being, or the plume being present where the sensor is. So again, by carrying out an average, which includes the troughs, means that you're averaging down not the emissions, but the lack of a plume where the sensor is. So the sensor itself and its placement is the concern here, more so than, not exclusively, but more so than the averaging approach. And my opinion is that if we were to assume, which I don't believe is correct, that the peak emissions occur within that first 37 minutes, then it would be appropriate to assume those peak emissions represent the concentrations that should be assessed, and we shouldn't be averaging them over a 10-minute period when doing an assessment. Just to expand on why I'm confident that the sensor is not representing the measurements of a plume, if I can take us to returning to my proof. And figure 3, which is on page 10 of the document. Figure 3 just shows a couple of screenshots from a video of one of the fire tests. The purpose of bringing you here is to look at the shape of the fire flame. In the top figure, it is sort of going vertical, and in the lower figure, the plume is going off to, in the image to the right. Now, if the sensor is located directly above the center point of the container, in the bottom image, it is far less likely that the plume will be where that, the sensor will be where that plume is, because the plume will be going off to the right. And that is the problem with measurements for sort of transient flames from fires in ambient conditions. Just to again reiterate why that is important, if I can now take you to, it's probably easiest to look at. If we jump to the plume assessment for the appellant, which is CD, excuse me, 131, I believe. Yep, 131. If we can take our eyes to the figures, just try and scroll down. Figure 0-3, which is on PDF page 16. No, it's A-4 page on our paper copy.
A hydrogen fluoride
Yeah.
contour plots.
So that figure, the reason for taking your eyes here is purely to demonstrate that this is a plume study which shows where the plume will go during a fire. It's obviously heavily relied on as part of evidence. But again, if we're looking at where the sensor would be, if that is in the center point of the container and about between 0.7 and 0.8 of a meter above the container, in all three of these images, the sensor would not be in that plume. It is, if the container is considered to be about 2.7 meters and about between 0.7 and 0.8 meters above that, the plume will not be in contact with the sensor. So therefore, you've got visual evidence of the flame not constantly being where the sensor is. You've got modelled evidence that the sensor won't necessarily be in the plume. So to rely entirely on that to demonstrate that that's the peak emissions would not be robust, in my opinion.
Thank you. And then finally on this topic, can we just deal with PFAS in particular? And there's been reference in the inquiry of PFAS being incinerated or destroyed at 900 degrees or above. And can I just have your thoughts on that question?
Certainly. So I understand that PFAS is discussed fairly significantly in the last sessions. So I won't go into huge amounts of detail about what they are, but obviously they are a collection of compounds of high concern because they last for a significant amount of time. But as has been sort of said in numerous evidence by the appellant, that it's considered that there's a high chance, that the high probability that PFAS will be destroyed because of combustion at high temperatures. Now, I will agree that to break down the bonds between the elements, that high temperatures are likely to do so. I think it's accepted that incineration, so for example, hazardous waste incineration, you would use high temperatures and a long dwell time to ensure that various different pollutants break down. My concerns with the statements without the evidence that's been presented are that in incineration, there's a requirement for 2-second residence time. What I mean by that is that the pollutant needs to be combusted at a high temperature for a significant period of time, 2 seconds or more, in order to break down the various different chemicals and bonds. In a fire like this, the time between emission, combustion, and out into the ambient environment where it will cool down will be a fraction of that. So it's not going to have a sufficient amount of time to be in a plume at a high temperature to break it down. So I'd expect that the PFAS that's released might be in the plume for half a second, certainly not sufficient time to fully break down and fully destroy all of the PFAS. There's also the challenges with, again, fire plumes like this and fires in ambient conditions, is that the fluctuating, moving nature of the flame means that at any specific point in space, the temperature will vary. There'll be points in the core which will be high temperatures, but there'll also be areas where it's much lower. So I don't think that there's enough time for PFAS to be fully destroyed or broken down at temperatures above 1,000 degrees. Now, I'm aware of, in the waste incineration industries, that the Swedish Environmental Research Institute conducted a study looking at waste incinerations and PFAS emissions, and this is in environments where the occurrence of incineration over 1,000 degrees for more than 2 seconds happens, so it's intentionally designed to break down, and the evidence is that in the soot that comes out from there are still PFAS emissions, which demonstrates that they haven't been fully broken down. So the Swedish Environmental Research Institute demonstrated there's PFAS emissions even when incineration at more than 1,000 degrees for 2 seconds. So it hasn't fully broken it down. My other point to note on here is that the PFAS emissions are likely to be bonded to other materials, so as it forms and bonded to soot or bonded to other elements. And so again, there's no evidence provided to give me confidence that PFAS will be fully destroyed in any way, shape or form.
Thank
Sorry,
you.
could you
Sorry,
repeat
Madam.
the second point? Because I'd got the Swiss study and then I hadn't kept up with you for the second point.
Sorry. So the key points are, the Swiss study showed that the PFAS emissions were not destroyed, that the dwell time, the residence time in the flame will not be sufficient to break it down, that PFAS will bond to other elements, so for example soot in the formation and particles, and once it's bonded to other particles, it again won't necessarily break down. So there's sufficient evidence that PFAS doesn't get broken down at high temperatures, in my view.
Thank you. If we then move on to a new topic, which is where the plume goes. So we've looked at what might be in it, and so we look at now where it goes. And can you start off with the the approach that was taken in the plume assessment? So what was modelled and what were the assumptions in the model?
Yep, certainly. So the appellant's assessment used a computational fluid dynamics model. This was done by a company called DNV. The computational fluid dynamics model was an in-house software package called KFX that they developed. They assumed that there was a single unit fire, that the unit was in the corner of the site, and they have focused on various thresholds and also considered visibility. They assumed 2 different wind directions for their assessment and 3 different wind speeds. And the computational fluid dynamics model concluded there would be no impacts at nearby residential properties, so Hillcrest, for example, and there'd be no visibility impacts at the nearby road.
Thank you. And then can you talk us through your assessment of where the plume may go in this case and the extent to which the modelling carried out by the appellant has captured that?
Yep. So it's worth starting by saying that obviously we don't know when a fire will occur, and I believe it's confirmed by both Mr. Lester's evidence and mine that a flame can go in any direction. So the direction can be in any way, and it will typically be along the prevailing wind. So we've got an assessment that's done, looked at just 2 directions, and that is fine from theirs, and those 2 directions selected are pointing towards the nearest residential receptor, which is useful. There's a concern about CFD modelling, which is the model approach that they have taken, and CFD modelling looks at how it resolves the Navier-Stokes equations, and it looks at how particles move around and flow. There are significant limitations in CFD modelling, which I've discussed in my evidence, and is also being confirmed by Mr. Lester's evidence as well, which I'll come into in a second. But the key thing, well, there's a few key things. One is the wind speed. If I can just take you to my evidence. and figure 7 on document page 18, so this is a demonstration of a figure of how different atmospheric conditions have an impact on the plume. So we've got a plume that comes out of the fire, and the CFD model is demonstrated there is a plume, and then it can go in various different directions. The way it behaves depends on various different things, and the key ones are wind speed, in wind direction, and the atmospheric stability. This has an impact on how spread out the plume is, or the opposite, how concentrated the plume is and how concentrated the concentrations are at relevant locations. So with higher wind speeds, you tend to get a narrower plume because it's getting blown in specific directions. And at lower wind speeds, it can be more fluctuating more and a wider spread. That's in terms of a horizontal spread, but you also have atmospheric conditions which can then suppress the plume spread, so it doesn't necessarily release up vertically. It can get held down into a lower level, more like ground level. And the limit and restrictions of a CFD model are that the modelling that's been done is it doesn't represent the range in atmospheric conditions. So it's not specific to the site in terms of what's going on. And the atmospheric conditions, which has been accepted by Mr. Lester's evidence, is that they can change significantly the concentrations predicted. So a CFD model can, in my opinion, is very effective at considering the near field concentrations. Near field being the first sort of 10 to 20 meters. There's less confidence in them the further away you go from the source. And that is because it can't take account of the full suite or range of atmospheric conditions, and it can massively underestimate the concentrations. So we've got a scenario where atmospheric stability is a key element which the modelling doesn't consider in any detail. And it certainly doesn't consider the range of stability conditions or what that could do to the modelling. So we know that it can go anywhere. We know that CFD has limitations. An alternative model such as a Gaussian plume model, which parameterizes the plume, though that type of model can account and consider for the range of different atmospheric conditions. And beyond the first 10 to 20 meters, those models are very effective at considering the impacts within the first few hundred meters and accounting for the range of uncertainties in different atmospheric conditions. So at the moment, we've got a study which I don't think represents the conditions that would occur at the nearest residential property in terms of what the actual model concentrations could be.
Thank you. So you dealt with what's in the plume and where it goes. If we then try and sort of pull this together to see where that takes us. And we look at it in terms of a source pathway receptor model. If we just look at pathways, what are the pathways that you and Mr. Lester have considered in this particular case?
So the pathways and the relevant receptors, which both Mr. Lester and I consider to be relevant, are the impact on residential receptors in the nearby area, so Hillcrest receptor, and other residential properties. There is the exposure within the site to first responders. However, that is less of a concern for me in terms of the evidence presented doesn't consider full detail at the residential receptor. So there's a clear pathway through a plume that can reach the residential receptors. There's also a pathway to the ground, which is you've got a plume that occurs. It contains pollutants, which are both gaseous and also a mass-based, so particles. That through deposition, those particles can come out of the plume and land on the ground, or through contact between the plumes, so physical impact. So if the plume, once it goes up, across and down in a very simplistic approach, once it impacts the ground, that physical impact can deposit matter on the ground. Matter can get deposited through deposition, for example, through wet deposition from rain, or from, in this case, as well, considering any fire water that's used nearby. So any water can lead to deposition of the pollutants onto the ground. Then there's mass-based dry deposition, which occurs through gravity. So you've got the particles getting pulled down through gravity, you've got particles getting pushed down through wet deposition, and you've got the impact of a plume landing on the ground. So there's three viable routes for pollutants to come in contact with the ground and be deposited on the ground.
Thank you. So those are the two main pathways and receptors. There's pathway to human receptors in the residential properties, and then a pathway to the ground through the three main methods that you've spoken about. To what extent can any of those pathways be broken or stopped through mitigation measures?
Once the plume is out of the battery container, so once the fire's occurred and the plume is coming out, there are no measures which the appellant can implement that would prevent or change the direction or where that plume would go. It is down to atmospheric conditions.
Thank you. Okay, so if we deal with deposition first and then impact on residential receptors. And in terms of deposition, what I'd be interested to hear from you is what is the evidence that the inspector has on what's likely to be deposited at what concentrations and how that relates to any sort of recognised threshold or standard? What do we have from the appellant?
In the appellant's original plume study, there was no evidence provided on the level of deposition that would occur. It considered exclusively the ambient concentrations. It did consider particulate matter emissions, not through measurements, so they didn't measure the amount of particulate matter or soot that would come out from flame. They speculated based on a diesel fire of the level of emissions that would occur. So there's no measurements that's based on. And the modelling only considered the ambient conditions, so no deposition was accounted for in the original plume assessment.
Thank you. If we then move on to human receptors, if we take this in stages, there's a dispute about what the correct threshold, what threshold should be used. Can you explain what the various thresholds are that are referred to in the evidence and which one you say is the most appropriate in this case?
So the plume assessment, which was carried out by the appellant originally, which is CD 131, focused on a series of thresholds to test whether exposure is acceptable or not. Now, as I've set out in my evidence, that I believe that they omitted consideration of one of the relevant thresholds. There is, in my view, important to consider a threshold which is the acute exposure guideline level, which considers level 1, which represents discomfort impacts. The reason I think this is relevant for the inspector is because both UKHSA, in a letter which I will bring us to now, refers to such levels as being relevant for BES fires. So bear with me a second and I will take us to it. So CD 15.6 This is a letter from the UK Health Security Agency regarding a different BES assessment. However, in the response to the fire safety and air quality assessments, sorry, one sec. The bottom of the first page, it refers to, if I read out this, so in the context of that assessment, the design failure renders the air quality modelling and its conclusion of no noticeable discomfort as unreliable and insufficient to safeguard the community. The implication here is that in order to safeguard the community, a no noticeable discomfort conclusion is required. And on the second page at the top of the page, the paragraph continues and it makes reference to the acute exposure guideline level 1, which refers to the analysis that was carried out. But I see this as UKHSA's stating that the relevant level for this is the air quality exposure guideline level 1 threshold. I also wanted to just... So let us got two.
Just a moment, gentlemen.
So the question was regarding just the reference to the acute exposure guideline level, and the second line of page 2 of the letter makes reference to the acute exposure guideline level. So that's where it's referenced. But the key
If you
point...
could just go over the point about the previous page as well, just in case anyone had missed that. Thank you.
Yeah, of course. So the the first page of the letter in section 1, which is the fire safety and air quality assessment. This was a review by UKHSA and looking at the assessment that was submitted in relation to that assessment for different BES sites. However, the key point here is that in order to safeguard the community, that a conclusion of no noticeable discomfort is required, which is in section 1. It is the second paragraph, last line. It's referring to that. Just to add to why I think that these thresholds are relevant in a different application, but for the Environment Agency, will consider this threshold, so the AEGL1 level, when considering applications for data centres and the operation of backup generators. So in an emergency scenario, they will consider and expect information on this threshold to be presented when doing those assessments. And so the Environment Agency, while recognising they are not a statutory requirement, recognise that they represent health concerns for the community in an emergency response situation. One of the other things that the DMV Plume study does is it makes reference to wells, so the work exposure limits, levels, sorry. And these are published by HSE, and these represent levels that are the working population, so workers, so wells represent levels which protect workers. My concern in using wells exclusively, which is one of the levels which they have considered, and Mr. Lester suggests is the appropriate level, is that the Environment Agency, again, if I can take you to CD 15.7, this is information from the Environment Agency on deriving environmental assessment levels. So CD 15.7. And then page 6 of the document, not of the PDF. So this document overall is about how the Environment Agency has developed and derived environmental assessment levels for considering the levels required to protect human health. So that's what this document's setting out. And on page 6, it talks about comparing the wells, so the work exposure limits, to the EALs, so the environmental assessment levels that the Environment Agency consider to be relevant. The paragraph, they're not numbered, so under section 4.1, I think it's the third paragraph, sorry, the fourth paragraph down, starts off, for example. This one on the last sentence, and I'll explain why in a second, but the last sentence says, the implication is that deriving EALs, so exposure assessment levels for protecting human health, from wells may not be providing the necessary protection to human health. So reliance exclusively on wells will not provide the necessary protection to human health based on the Environment Agency. And on the following page of that document, there is a table, table 1. Oh, sorry, I've just lost one of these. This is just a comparison for them, but if we look at the example which I've been using today of hydrogen fluoride, it's about halfway down the table. On the far right-hand column is the ratio between the well and the environmental impact assessment level that they would consider, and it's a factor of 2. So they're suggesting there that the well is half as protective as an EAL that they would use for assessing impacts. Point being that the wells are not protective of health. So my belief is that the air quality exposure guideline level 1 is the appropriate level for considering health in the community and in the local environments.
Thank you. So that's the appropriate threshold. And then can you set out what the evidence shows us in terms of concentrations at Hillcrest, for example, which I think is the nearest residential receptor?
Yeah, so the thresholds, the AEGL1, they are set thresholds at different time periods. So 10 minutes, 10-minute average exposure through to an 8-hour exposure. And the plume study carried out by the appellant, so the DNV model, presents no information on the concentrations at the nearest residential receptor. So I am not in a position at the moment to say what the concentrations are at that residential receptor. What I appreciate has been done in Mr. Lester's rebuttal so if I take you to CD 14.5, so on figure 2, on page 5, it provides an updated revised figure showing the plume from the DMV model, so the CFD model, computational fluid dynamic model, that was done representing the area where the exceedance of 1 ppm, so part per million, occurs, and this is the threshold for the AEGL1. So that is the threshold, and I accept that. However, my concern here is that, as I've said earlier, the type of model that's been used represents the concentrations in the near field of the first 10 to 20 meters, but it doesn't do a good job of representing the concentrations at a few hundred meters away. And to expand on that, well, I'll finish off before we leave this page. So figure 2 of Mr. Lester's rebuttal shows and suggests that the area where the 1 ppm threshold will be exceeded will be about 25 meters from the fire. What we don't know is what's going on further away and at the residential property. So there's no evidence put before me or yourself, Ma'am, that of the concentrations at the residential property about 225 meters to the north. And why this is relevant is that the type of modelling that's been done has large uncertainty because it doesn't account for the various stability and the real atmospheric conditions that are occurring. So while it can be fairly good, reliable in the near field, so the first 10 to 20 meters, as you start to get further away, that uncertainty becomes significant. If we come to in fact, we can stay on Mr. Lester's rebuttal. So Mr. Lester's rebuttal on page 10 in Appendix B, there is a figure A1 which is based on, which is an extract from a study, which I refer to in my own evidence as well. What this is showing, and this is a plot that's showing predictions from the same model that was used, the CFD model that's used by the DNV plume assessment. Mr. Lester's used this to imply that the uncertainty in stability and meteorological conditions, which hasn't been accounted for, is not relevant within the first 10 to 20 meters. And I actually agree with that. What the figure is showing, there's three different lines. There's dashed lines, dotted lines, and a solid line. And these three different lines are the attempt by the CFD model to account for turbulence, so accounting for the stability of the atmosphere. So this paper is demonstrating that for the model that was used for CFD, that, I should say, sorry, the x-axis is the distance from the source, so from the fire. Goes from 100 meters, 200 meters, 300 meters, 400 meters. The y-axis is a concentration of a pollutant in a logarithmic scale. Now, if you go up to, say, the different stability or turbulence values show that the lines largely overlap within the first 10 to 20 meters. However, when you get out to where the residential property is, at about 225 meters, the range in concentrations, bear in mind it's a logarithmic scale, is significant. So the predictions that are occurring from the CFD model at the residential property could be massively under-predicting. The absence of presenting what the concentrations are at the residential property means that we have no way of accounting for that uncertainty, no way of knowing whether that, once accounting for that uncertainty, whether that will trigger exceeding the threshold of 1 ppm. So that the reality is we don't know the concentrations at that residential property based on the CFD model that was done, accounting for the accepted uncertainties in that model and the approach. And just to reiterate, that's uncertainty associated with the stability in the atmosphere. In terms of the emissions, there's still uncertainty in the emissions as well. So there are multiple levels of uncertainty that are occurring. And Mr. Lester's interpretation of this error is that the emissions, the use of a high level of emissions outweighs the other uncertainties, of which I don't believe there is evidence to agree with that.
Thank you, Mr. Lister. Is there anything more you want to say on residential properties or indeed on any other topic before we finish up?
The key thing I would say is that it is well practiced to use a Gaussian plume model, such as an ADMS, and that would have provided the information to account for these uncertainties. So it's possible to have done modeling which accounts for these uncertainties, and that would have provided the information, the evidence, but that's not been made available. In my experience of modeling and using a Gaussian plume model and looking at concentrations a few hundred meters away, there is a risk of a breach of the 1 ppm threshold, so which is the same level as distance as the receptor. So there is a risk that could be exceeded, and it is possible to demonstrate that if modelling was done.
Thank you. Ms. Laxton, if that's it, madam, those are all my questions. Thank you.
Okay, thank you. Ms Osman-Smith?
Would now be a good time to take a short comfort break? Thank you.
Okay, we shall do that. If I could just remind the witness of the position that you're in. You're fully aware. Thank you very much for that. Shall we take a break until 22 by the council's clock? Okay, is that okay? All right, thank you very much. We're adjourned until 22. Thank you. Okay, we are reconvened. Are you ready?
Thank you very much, Madam, and good morning, Mr. Laxon.
Morning.
We'll work this out. I'm sure we'll be on top of the logistics very quickly. Mr. Laxon, you're going to need, which I'm sure you have already, your proof of evidence, Mr. Lester's proof and rebuttal, Mr. Blunden's proof and rebuttal, the site safety report, which is core document 1.36, the plan at core document 1.47, which is compliance with NFCC design guidance, and the plume impact assessment, which I'm sure you've got close to hand anyway. Okay. Mr. Laxon, you, I think, have assisted in the promotion of battery energy storage schemes, haven't you?
Say I missed the start of the sentence.
Yes. My understanding is that you've assisted in the promotion of battery energy storage schemes.
By promotion,
Acting on behalf of applicants.
I've done studies for developers and for other sides as well, yes.
Those are sites that are proposed for battery energy storage systems where you have provided supporting information that goes in with the application.
I've done modelling studies, yes.
Those modelling studies, I think, were you involved in the Heckington Fen DCO?
I don't recollect the specific one. I've done various studies. Yeah.
Yeah. And essentially, am I right in saying that the outcome of your studies was that the air quality impacts of a fire at a BESS scheme were acceptable?
Every site's specific, and so I'm not able to make comments on other ones without the evidence in front of me to recap.
I ask, have you recommended to a client promoting a battery energy storage scheme that in the event of a fire, the impacts to air quality would be acceptable?
I've carried out studies which have shown, in the specific circumstances, with relevant exposure considered, that there are no impacts.
Okay, thank you very much. With all BESS schemes, Mr. Laxon, if something goes wrong and fire occurs, there is likely to be a release of airborne pollutants, yes?
That is correct.
So that's all BESS schemes, not just this BESS scheme. And part of your evidence is that assuming that there are more than 100 gigawatt hours in this country in the near future, that could equate to 10 fires a year. That's what you say at paragraph 10.4 of your evidence.
That is what my evidence says, yes.
What we know from the EPRI database is that at the close of 2025, BESS capacity worldwide stood at 610 gigawatt hours. Are you familiar with that figure?
I'm not familiar with that figure off the top of my head. However, I am content that it is changing as an evolving number.
Those are the figures. We discussed them last week, but I need to test this point because it comes up in your evidence. At the end of 2025, worldwide BESS capacity was 610 gigawatt hours, and there were 10 recorded fires that year. So 10 fires in the context of 610 gigawatt hours. That doesn't support your calculation that 100 gigawatt hours of batteries is likely to lead to 10 fire incidents, does it?
So in terms of my evidence, second, sorry? So I'm content to rely on Professor Ramsden's evidence based on probability. I understand it discussed extents last week in the previous sessions, and I am happy to rely on that evidence in terms of that and focus on the plume studies for my evidence.
Yeah, so if I can understand, your 10 recorded fires that you say could arise from 100 gigawatt hours of batteries, that's based on Professor Ramsden's evidence.
I am happy to the conversations.
I'm not asking you if you're happy to rely on his evidence. I'm asking you about your specific figure that you have quoted to the inquiry, your proof of evidence, 10.4, where you say, assuming there's more than 100 gigawatt hours in the near future, that could equate to 10 fires a year. What is your evidence to support that figure?
My evidence is setting out that a fire may occur. That is what my evidence is doing. And then in order to then demonstrate that we don't know where it will occur, that is what my evidence is saying. So I'm confident that it's been demonstrated that a fire can occur from a bed site in England, and therefore it needs to be considered what the impacts of a fire are.
If that's as far as the point goes, then I don't think there's an issue between us, because we wouldn't have been sat here for days and still yet more time to come if everyone didn't agree that a fire at a BESS was a possibility. But you give a very specific figure, which is 10 fires for 100 gigawatt hours. The evidence, that is the database, which demonstrates 610 gigawatt hours capacity at the end of 2025 and 10 fires that year, does not support that figure, does it, Mr. Laxon? And I would appreciate a yes or a no.
I haven't looked at the 2025 data. I understand it was discussed last week. My evidence is based on the information in the previous paragraph, so 10.3, and that's where my evidence comes from.
Okay, thank you. Well, that's useful to understand the source of that. What we know from the Clean Flexibility Roadmap, so that's the core document at 11.2. So 11.2 is the Clean Flexibility Roadmap. And if you go within that to page 40 of the PDF, and in fact of the document itself under the heading Safety, you'll see a paragraph beginning grid-scale batteries, yeah? And that tells us grid-scale batteries pose no greater danger than other infrastructure. But where I want to take you to is the final two sentences of this paragraph, where it says, fires at grid-scale battery sites appear to be less likely than those at non-domestic buildings in general from all sources. The latest available 5-year annual average fire incidence rate for GB batteries is 0.7, lower than that for wider non-domestic building fires in England, and that's put at 0.8. Do you see that?
I see the sentence, yes.
We know from that that the likelihood of fire at non-domestic buildings is higher than BESS, and the release of contaminants in those events is no different, or rather the point is this, that there is likely to be a release of contaminants from battery energy storage systems and also from non-domestic buildings, yeah?
There is likely to be emissions from fires, yes.
That's a fair way of putting it. If fires happen, and they are of course all unfortunate, but there are likely to be pollutants released into the atmosphere, yeah?
Yes.
And of course, it's not just buildings, but vehicles on the road, lorries, other trucks used for transporting goods and fuel, for example, they may set alight and also could cause polluting emissions to enter into the atmosphere.
I think fires will produce emissions, yes. I would say that it does. The specifics are obviously the key part in it, in terms of relevant pollutants and proximity to receptors.
And as a general rule, air quality assessments are carried out to understand operational emissions of development under ordinary conditions, correct?
I've carried out many air quality assessments for abnormal conditions in emergency scenarios, such as just parallel examples, obviously BES schemes is one of them, such as data centers, testing the emergency operations of generators. So it's well practiced to do assessments for non-ordinary operations.
Let's just have a think about that, actually. It is more common, isn't it, to do air quality assessments for the ordinary operation of development?
It depends entirely on what the development is. If the source of emission is going to be from, say, a backup source or an emergency operation source, then I would expect the impact of that development to be assessed, and that's certainly what I would do.
So, for example, we are used to dealing with, for industrial development, assessing the emissions from manufacturing process, for housing schemes, for example, understanding the air quality emissions arising from development that is expected to generate a lot of car movements. And the inspector will, of course, have seen many of those assessments, but it is more unusual. I don't say it's immaterial because we've all done it here. But it is more unusual to carry out air quality assessments on the assumption that something goes wrong.
Air quality assessments are carried out to demonstrate the risk of the consequence. So and a part of that is considering the impacts and the breach of something, and considering whether or not they is appropriate use of the land. So it's any emission source needs to be considered.
Yeah, and understanding the consequences, yes, but does the consequence arise from ordinary operation or in the event of a fire? And we are all used to seeing air quality impact assessments based on ordinary operation, whether it's industrial, whether it's warehousing, whether it's housing development. My question to you is not that it hasn't been done or should never be done, but it is unusual to carry out an air quality assessment on the assumption that a development is going to catch fire and go wrong. Yes or no?
No, it's not unusual to do an assessment of non-operational abnormal conditions.
No, that's your evidence. It's not unusual to do an air quality assessment based on something like a fire event that is outside of the ordinary course of events.
My evidence is that I have personally done assessments for abnormal operations, so not a normal operation, and they have supported various different planning applications and developments. So for me, it is not unusual.
More unusual than air quality assessments based on ordinary operation, though. Agreed?
I've done more normal operation ones than I have.
And the government accepts that there are risks associated with BES systems. Yep, we can see that set out in the guidance.
I agree.
But in that context, it remains supportive of a significant increase in this technology, yeah?
I mean, that's policy that's beyond my evidence here, but I'm happy to say that there is support for it, and that the guidance is looking at the specific sites and the specific exposure.
And you do say that in your evidence, you do acknowledge that government support, but it's important, isn't it, when we're looking at that government support for battery energy systems, that it acknowledges that there is a risk of fire. What the guidance does not set out, for example, is any specific distance that BES should be from, for example, residential receptors.
What specific guidance document are you referring to?
Any guidance. There is no guidance which says. There is no guidance which says, because I'm sure you would have brought it to this inspector's attention if there was, that when one is citing a BESS scheme, it must stay X meters away from residential receptors for the purposes of air quality, for example. Doesn't exist.
So I cannot explicitly say that there is no guidance. I believe I've seen a guidance document which recommends that there are proximity distances. I don't have it to hand. But I believe the DESNES guidance on health and safety and grid-scale electrical energy storage systems does make reference to distances. But I apologise, I don't have that to hand at the moment.
Perhaps we can come back to that when you've been able to find, or my learned friend can take you to that if that's what it says in due course. When we look at guidance in relation to grid scale BESS and the exercise which we're involved in, which is understanding the emissions to air, we don't see a requirement, do we, to undertake modelling of air pollution in a prescribed way?
The UK approach to assess...
For a minute. When I'm asking you a question, what I would really appreciate is a yes or no answer to the question I've asked, and then I'm sure you want to add to it, qualify it, expand upon it, that's fine. But I will ask you again if I don't get an answer that I can record properly for my own notes. So if we can do that again, when we look at the guidance related to grid scale BESS as we have here, we do not see a requirement to undertake modelling of air pollution in a prescribed way, yes or no?
That is correct. The caveat to that is that the UK approach to assessment is not prescriptive for any assessment, normal operation, abnormal operation, planning or permitting. It's evidence-based and information-based. So there is, for any emission source, there is not a prescribed way to do it.
Yeah, and judgment is involved, correct?
That is correct, by a competent expert.
And what you don't say to this inspector is that the plume study that was carried out in this case was carried out by people who are not to be regarded as competent experts.
Sorry, so I don't say that they're not competent experts. So
You can agree that the plume study was carried out by competent experts. Agreed?
I haven't got the details of them, but I'm confident they are capable of modelling in the CFD model that they have done, subject to caveats I've already said in my evidence about that type of model.
And there is, isn't there, a legitimate choice between the model that one uses. So we've discussed two. We've got CFD, computational flow diagram, which is the model that was used in the Plume study here, and one that you've brought up in discussion in your evidence, the Gaussian model, there is a legitimate choice between the two, isn't there? And that's a matter of judgment for the particular assessor.
There is a choice, yes. And I would say that they are both capable of doing different things and can be used complementary as well. So there's not a binary choice. There are two tools to provide evidence, and depending on what you're trying to evidence and what you're trying to look at, one may be more appropriate than the other.
There is no reference at all to PFAS in the guidance when we look at the way in which grid-scale batteries should be assessed.
I believe that is correct. I don't see specific reference to how you assess other pollutants in detail either.
What there is a requirement to consult the fire service in light of the NFCC's guidance. And in the case of emergency, specifically for emergency, ensure that there is a robust emergency response plan as part of the scheme proposed. Agreed?
I agree.
There are, of course, many BESS schemes that have been consented in the UK and constructed which give rise to similar, perhaps even greater risks than this scheme, depending upon the technology used, and all, of course, would give rise to emissions if there was a fire event. Not all schemes are supported by large-scale fire testing and monitoring of emissions as we have in this case. That's correct, isn't it?
That is correct.
And in fact, I'm sure, Mr. Laxon, that you've carried out assessments of potential air quality impacts from fire at a BESS that have had to make assumptions because there haven't been any tests such as we have here to monitor emissions from a fully involved fire of an entire BESS cabinet. Is that right?
In conducting studies, I have made assumptions, yes, that's correct.
So you've had to make assumptions because you didn't have the level of detail that we've got provided in respect of the particular technology that is proposed to be deployed at this site should permission be forthcoming. Yeah?
I've made assumptions because I've not had emissions data. That is correct. I would say that, as I said earlier, the literature reviews and reported evidence of emissions are available, and what most the emissions testing, as I discussed earlier, doesn't necessarily change the outcome of those emissions that are reported in studies.
Just thinking about the position that we have here, it is unusual in this way that we have a fully involved large-scale fire test of a BESS cabinet. And we have, as a result of that, a record of the emissions. And I understand you make criticisms of the way in which that was tested, and we'll come on to that in due course. But we are in a position of having the best information available for this specific type of technology in this inquiry, yes?
I agree that we have useful information. I would say that it is becoming a requirement to do such tests, and I would expect that we would end up with significant more information going forwards.
Yeah, I think that's fair. It wasn't something that has been done historically or was required to be done as part of BESS applications, yeah?
Correct.
So what needs to be understood in any particular case is how the impacts of any fire event are to be managed and the mitigation effects that apply in the circumstances of any particular case in this site specifically. And that can be achieved, for example, by active mitigation, by which I mean the design of the battery system selected, the drainage systems, that's obviously outside of your area of expertise, but those are active mitigation measures, or passive mitigation measures such as the distance to receptors or the presence of woodland, for example. Those are all going to be relevant factors when considering dispersion, when considering the pathway of emissions to ground.
Distance and obstacles will have have an impact on the dispersion. I agree with that.
And then we've got the permeability of the site and adjacent soils, which I know isn't for you. We're going to hear a little bit more about that later on. Part of your evidence raises queries over the nature and scale of the hazard. And we've touched on that a little bit in terms of your 10 fires point. But what you also say is that there is some issue over what's proposed here in terms of the capacity of the unit. I assume that you've read the rebuttal produced by Mr. Blunden to that. Do you understand that what is proposed here is the Wärtsilä Quantum 1 cabinet with a stored capacity of 1.49 megawatt hours?
Yes, I understand that in my original proof, it was unclear to me that in the rebuttal, it has been stated what the intention is.
You're clear about that now, are you, Mr. Laxon?
Correct.
And it is that particular technology that has been tested and has provided the results upon which you've based your evidence. You set that out at 7.4, yeah?
I was just getting to that paragraph. So what was the question again? Apologies.
So what we have is the testing for the Quantum 1 unit. That's what's been provided. That's what you acknowledge at your 7.4. Your point is that there could be an overall increase in capacity or a different technology could be used, which doesn't reflect the data that you've seen. But are you satisfied that what is proposed matches the data? It was the Quantum 1 that was involved in the large-scale fire test that yielded the results that you've been able to use in your evidence.
Yes, I'm satisfied to the best of my knowledge of that.
Okay, so that point is resolved. You also talk about separation distances a lot in your evidence, and we'll come on to see some of the ways in which you set that out in due course. There are two relevant distances here. That is the 0.1 metres between individual cabinets, which are then put together in strings. That's one of your two significant points of concern that you list at 15.1 on your page 29 of your proof. If you want to turn that up. So significant points of significant concern, the 0.1 spacing of the battery units. So that's how we look at the strings. It's 0.1 between cabinets in the string. And then there's the 3.2 distance between the rows. Yeah? Those are the two separations.
Yes, I understand.
The point you make in your proof of evidence is that Devon and Somerset Fire and Rescue Services may have been unclear as to the separation distances here.
In my interpretation, as I set out in 7.8, I say it's unclear to me how they responded to that 0.1 separation, yes.
If you still maintain that point, let's have a look at what we can discern from their response, which is core document 1.36. That's the site safety report. Can you go there, please? And when you get there, if you go down to page 45 of the PDF, 45 of 65. Or it's Appendix 2, Madam, which is the Fire Service consultation response. So what we have there is the letter from the Fire Service. And helpfully, at the bottom of the first page, they list the documents that they've had regard to in providing their response. Do you see that?
Yes.
And one of those is a compliance with the NFCC design guidance fire strategy plan. You see that listed? It's the second bullet point up from the bottom.
Yes.
And if you turn to core document 1.47, core document 1.47, you'll see there we've got the drawing title is Axminster Energy Hub Compliance with NFCC Design Guidance, and then over on the left-hand side we've got Fire Strategy Plan in the bottom left-hand corner. So this looks like a pretty good candidate for what the fire service were looking at. And we can see there, can't we, the layout both of the strings and the rows across the site, you see?
Yes.
So we know that when the fire service were responding, they had this plan showing the layout, where all the cabinets were, and they also had a scale on this plan provided to them in the bottom left-hand corner, yeah?
Yes.
And what they say in their letter, if we scroll down to the second page, page 2 of 5, of the fire service response, you'll see a paragraph, second paragraph up, beginning regarding the spacing.
Yep.
And what they say there is regarding the spacing between strings of cabinets, Wartzilla recommends a minimum distance of 3 metres, while the applicant has proposed a distance of 3.2 metres. These proposed distances comply with the NFPA 855 standard, but do not meet those recommended by the NFCC guidance, you see?
Yes, I see the paragraph.
So they're saying there is a distance between strings of cabinets, which they understand is more than one unit put together to form a string, yeah?
I agree that there's a distance between strings, yes.
But what's a string? A string is units put together.
Yes.
So they've acknowledged that a string is a unit put together and that there is a distance then between strings in terms of the cabinets, which should be at 3 metres according to Wartzilla's design guidance, but what's been provided here is 3.2. But if we look over, it's even clearer that they've understood how all of this works on the following page, because what we've got there is to support the proposed separation distance of 3.2 metres, the applicant has provided reports by Fire and Risk Alliance, a third party who specialise in fire protection, design and hazard and risk assessment. The reports, which are based on results using data obtained from CFD modelling and large-scale physical tests, demonstrate it is unlikely that the design of the cabinets and the fire loading within them will lead to heat fluxes of a sufficient level that promotes fire propagation to adjacent units within the same string of cabinets, or from one string of cabinets to a neighbouring string where a separation distance of 3 metres is used. Do you see that?
I do.
So we can agree that from those, it's clear that the fire service knew exactly what was proposed in terms of the arrangement of strings of BESS and then rows of BESS. They understood the difference and were satisfied with the layout that was proposed, yeah?
Yes, however, I would say that if I could just bring you back to Mr. Bunden's evidence that contests and states, this is, apologies, a core document. CD 6.4. So CD 6.4, Mr. Blunden's evidence. paragraph 2.21.
What was the paragraph number?
2.21. So 2.21, this is the appellant's expert, states in his evidence that the fire service does not specifically reference that they are connected together or the spacing is 10 centimetres. And that's something that was raised. And his professional interpretation is that they considered a row to be equivalent to a standard 20-foot or 40-foot beds container. So in terms of separation distances, he's referring to the distances between the strings. Now, I accept that the evidence put forward here is that the fire service were aware of separation distance of 10 centimetres. I accept that they relied on evidence about fire propagation, which I am happy to accept. Professor Ramsden's evidence about propagation between units to units, which brings into question of whether that's relevant or not. I accept that the fire service have assumed that that is correct, and that's been questioned. But Mr. Blunden's evidence is suggesting that an assessment has been based on a 20-foot or 40-foot beds container. And obviously the plume study, which is my area of expertise, relates to a single unit, not a full 20-foot or 40-foot container.
Forgive me, Mr. Blunden's point is that when you put 3 cabinets together, it's the equivalent of a size of a standard 20-foot. If you put 6 together, you get the equivalent of a 40-foot container. That doesn't change the results of the large-scale fire test, that fire doesn't propagate between individual cabinets.
So as I said before, I am happy to accept Professor Ramsden's evidence about propagation between units.
Yeah, I mean, that's what the Rule 6 party rely on. But what I'm exploring with you is the point in your proof of evidence that the fire service didn't know or understand what was proposed. And I think we've probably got there. The large-scale fire testing, we've covered that already in evidence with the fire experts. But again, you trespass onto that within your proof of evidence, and I just want to ask you just a couple of questions about that. Is it within your technical expertise to comment on the operation of the deflagration panels in these units?
I am happy to refer to Professor Ramsden's evidence regarding those units.
Right, so you don't make any of your own points about the deflagration panels or the effect that they had on the large-scale fire test results. Is that fair?
The evidence I've reviewed is the study which assumes that a fire occurs, and I've reviewed the evidence that assumes that they've been removed, and that's based on the large-scale fire testing. So what I've assessed and reviewed, and given an expert opinion on, is the scenario that's set forward about them being removed. And I am happy to say that if they have not been removed, that might change the assumptions that I might have made if I was doing a modelling study. But it's beyond my area of expertise to know.
That's where I wanted to get to, because as I had understood that was beyond your area of expertise. But when you're talking about the impact that they could make on the resulting study, then we would have to go there. But if you're content to rely on the evidence of the Rule 6 party's expert about that, that's fine. There is another point that you make about flames reaching adjacent units, and that's at 7.11 of your proof. So 7.11, you say this, that the visual review shows that flames can occur in the 0.1 metre gap between the battery units, albeit at the end of the fire event when it will be lower in intensity. The video only shows such flames towards the end of the fire, but in the event where the panels are not open or not removed, there is a clear potential for flames to be in the narrow gap between the battery units during the full intensity. In these circumstances, which were not tested, there's a greater potential for fire to spread to the units adjacent. Again, in terms of the potential for fire to spread, the large-scale fire test, and you're commenting on the end of this test, essentially, when those flames were observed as being in the gap. The large-scale fire test was a unit burning with full intensity for 8.5 hours. Yeah?
Intensity changes over time, but yes, it was burning.
Or if I can put it this way, it was a fully involved fire.
It was a fire, yes.
And during that time, no water was applied for boundary cooling or for firefighting.
Yes.
And fire didn't propagate in those circumstances where there was no intervention, no boundary cooling at all, yeah?
Based on the rapid review, as I say in my evidence, I did a very rapid review. That's appears to be the case, yes. But as I said before, I'm content with deferring to Professor Ramsden's evidence, who's looked at this in much more detail than I have.
Yeah, and Mr. Blunden, of course, explained there's now been 6 rounds of fire testing across the whole quantum family, and none of those have led to propagation between units. And what you don't do is bring any evidence to the inquiry of any large-scale fire tests that show a different result in respect of this particular proposed technology.
The only large-scale fire test is the single one that's been presented for this study that I've seen. I'm not aware of the other 6 that you referred to from Mr. Blunden.
Well, I appreciate you weren't here for his evidence. You agree in your proof of evidence with the baseline assumption in the DNV plume assessment, which is cell-to-cell, module-to-module, and rack-to-rack propagation, yeah?
Yes.
What you say is that propagation of fire from one unit to another hasn't been assessed.
So if one container, yeah, correct, that hasn't been assessed.
And that's because the large-scale fire test demonstrated that wasn't the outcome. The result of the fire testing shows the opposite of unit-to-unit propagation, doesn't it? Didn't happen.
Once again, I defer into Professor Ramsden's evidence on terms of propagation from unit to unit. My opinion is if a unit-to-unit fire did happen, the impacts would be greater, that the evidence has not been presented in terms of what that would be, and the only evidence that's been presented to the inspector is in regards to a single unit fire. And if there was a propagation, that it would, which I said, Professor Ramsden evidence is regarding that, and I am saying that if there was an additional one, there would be a greater impact.
And that might be a legitimate concern in the absence of large-scale fire testing, which show the opposite happens. So thinking about, we were talking about BESS systems which have come forward in the UK in recent times and haven't been supported by large-scale fire testings, then you might have a cause for concern if, for example, those were based on only one of the units having a fire event and that fire not propagating if there was no evidence to support that propagation didn't happen. But we have evidence here, don't we? And the only evidence shows fire did not propagate.
As I've said, Professor Ramsden's evidence, as I understand it, has addressed whether or not propagation from unit to unit will happen. My evidence is related to if there was propagation, then the outcome would be different. The evidence presented in terms of the air emissions from a single unit is what's been available to the inspector.
One of the significant concerns you raise is the lack of information regarding the potential for deposition of pollutants from the air onto the ground and then from there into the groundwater, yeah? And you mentioned PFAS specifically in that respect.
Yes, I raised that.
again, it's a question about the scope of your expertise. So you make the point about, well, this could be in the plume, and there are pathways that would bring that to ground. In terms of that getting into the groundwater, that's a Mr. Carpenter point, I think, isn't it?
That pathway beyond deposition within the ground is not my evidence, yes.
Thank you. Good. Well, we're going to look then at the plume assessment and emissions. And do you agree, Mr. Laxon, that the right pollutants were considered as part of the assessment other than PFAS? Is that correct? Seven point 17 on page 12 of your proof.
I agree that those are pollutants that are relevant. My 720 points out that metals and PFAS were not considered, and that the assessment in relation to particulate matter was based on an indicative diesel fire, which may be incorrect.
Okay, there's a difference between not assessing something and using assumptions to try and assess something. The particulate matter and the diesel fire issue, it's been taken into account. You disagree with the way it's been taken into account, that's different. In terms of what's left out of account, so you say PFAS, you also say metals such as copper, iron and aluminium. Do you make a specific point about copper, iron and aluminium?
My evidence is that there is an absence of evidence in terms of these are metals that can get into the system and that they can have an impact.
We're going to come and have a look at that then in due course. Mr. Fellows has responded to that. But when we're looking at the plume assessment and the emissions, I think we've got 2 points to consider. What are the emissions and what happens once they escape from the fire? Most of the detail in your evidence focuses on PFAS and hydrogen fluoride. Is that fair?
I have used those as, well, hydrogen fluoride in particular, to represent what's happening in terms of gaseous pollutants, and PFAS to demonstrate what's happening in regards to a pollutant that's been missing. Yep.
And you chose hydrogen fluoride for a specific reason, I think, because effectively it's the worst pollutant?
It won't be the worst pollutant in terms of the impacts, but it's a pollutant which there's more evidence out there to corroborate or disagree with the evidence that's been presented, and demonstrates what's going on.
And some of the key conclusions that you set out are from 11.11 of your proof, and I think we probably need to turn that up on page 25. So what you set out from 11.11 on page 25 is that the modelling undertaken by your team at Calico for a theoretical fire at the best predicts that for a fire in a single container based on a storage capacity of around 1 megawatts, which you say is not clear, see the earlier paragraphs, effects due to, for example, hydrogen fluoride emissions over the following distances could occur. And we've got between 30 metres and 2 kilometres. That's effects likely but are not disabling and are transient and reversible upon cessation of exposure, no serious threat to human health or life, only discomfort, yeah?
That is correct, yeah.
And then the closer you come, approximately 30 minutes or 30 metres, forgive me, or 10 metres to the fire, then the effects are worse. But we appreciate that those distances would effectively be within a cordon set up by the fire service in the event of a fire, yeah?
Yes, and obviously, as I said before, just to make it clear that that first bullet point reflects the acute exposure guideline level 1, which I was discussing earlier, which represents what UKHSA and the Environment Agency have considered as relevant threshold.
Yeah, we're going to come on to those in due course, but you effectively summarise this at 11.13, that whilst you have not carried out a modelling study of the specific BESS in part due to the lack of credible evidence of no fire propagation between battery units at 0.1 metre separation distance, and despite the shortcomings of the plume assessment, based on the findings of my previous assessments in relation to ambient concentrations and the direct impacts on human exposure, I believe the risk to residents at properties over 200 metres will be discomfort rather than disabling or life-threatening. These can still be considered significant effects, but are less likely to be long-lasting. However, because of the shortcomings of the plume assessment, you believe insufficient evidence has been given to overcome your particular concerns. So let's just break that down. The first thing that you say is that you haven't carried out a modelling study of this specific BESS site, yeah?
I have not carried out a study of that site, yes.
You could have done as part of your evidence, couldn't you?
I was provided relevant information very last minute, but I could have done a study, but I am confident in my evidence in the same way that the DMV plume assessment wasn't particularly specific to the site because it didn't assess the turbulent conditions, didn't assess what's actually going on. The other studies I have done would be transferable and would be relevant and represent what's going on. So I'm confident I can say what I've said in paragraph 11.11 as being relevant for this site.
I understand your confidence in it, but when we look at the best evidence that the inspector has, a study modelling the impacts of emissions from this site, the best evidence in respect of this technology here is the plume impact study that has been submitted on behalf of the appellant.
No. The evidence has been made available with high uncertainties at the residential property, which we've established is a couple hundred metres away. The DMV study, the plume assessment study, doesn't model the likely concentrations at that location because of the shortcomings of the type of model that's used.
My question wasn't, is the information that's been put before the inspector perfect? And you're entitled to disagree with it, and you have disagreed with it, but what you don't present is alternative modelling for the inspector to rely on, do you?
I've presented... Yes or no? Apologies. I've not presented alternative modelling for this site. I have presented alternative evidence which is relevant for the site. That I don't, from my interpretation of reading Mr. Lester's evidence, he is not disagreeing with the fact that impacts can occur within the first few hundred metres as well.
Yeah, there are lots of points of agreement between you and Mr. Lester, but what I'm trying to establish is what the inspector can rely on. And there is a difference between criticising the study that's been done and providing your own evidence on modelling based on that exercise, which you haven't done. But where does this all get us, we ask? Because at 11:13, what you say is that the risk to residents over 200 metres will be discomfort rather than disabling or life-threatening, which is the language used by AGL1, yeah?
Yes.
And the closest residential receptor we know is beyond that at 225 metres, yeah?
So the distance is 225 metres. My evidence saying that it's going to occur beyond 200 metres. So apologies.
It's understood that. But Hillcrest is going to be in that category of discomfort rather than there being a serious issue to human health or life, yeah?
Yes.
You say that impact is significant nonetheless, but help me with this. A low likelihood of an event occurring that does not represent a serious risk to human health or life is not an automatic reason to refuse planning permission for this site, is it?
Sorry, could you just say that again?
You essentially land on effects that are likely but not disabling and are transient and reversible upon the cessation of exposure. That's where you get to for the nearest residential receptor, agreed?
Correct.
So a low likelihood of an event occurring that does not represent a serious risk to human health or life is not an automatic reason to refuse planning permission, is it?
I believe that if there's a risk to residents, that is a material consideration in a planning one. So I also don't think it's an automatic. I'm not aware of many automatic reasons for refusals in relation to air quality assessments.
Well, let's put it this way. If you were to come to this inquiry and said that a fire at this site did represent a serious risk to human health or life, that would be a compelling reason to refuse development of this scheme, wouldn't it?
That certainly would, and as I've said before, the impacts on residents considering discomfort has been demonstrated by UKHSA as a relevant level for considering planning applications from BES sites.
If your point is that are the AEGLs material, I don't think anyone disagrees with that. Mr. Lester has dealt with them in his own evidence now, hasn't he? You've seen those in his rebuttal. The point is to understand where on the scale we land. And it's not part of your case that a fire at this location would give rise to a serious risk to human health or life, is it?
Yes, in terms of human health, in terms of life, yes, I agree with that, as my evidence has said.
We're agreed. The high point of your case in respect of sensitive residential receptors, as you set out at 11.11, is effects likely but not disabling, transient and reversible upon cessation of exposure. Agreed?
Agreed, yes.
Okay, dealing then with the copper, iron and aluminium that weren't considered in the plume assessment, there are no relevant air quality standards for those pollutants, are there? Are you doing a quick Google?
Not at all. I'm trying to just find the reference to so there are relevant standards for copper, and there is.
Forgive me how we approach this, because where this gets us to is if they're deposited to ground, what Mr. Fellow says is that those are all naturally occurring metals found in abundance in the soil, and they're not a cause of concern. Now you say, well, the study was carried out and it didn't assess these, but where does it get us? I need to understand where it gets us.
So I haven't raised it as a significant issue in my evidence. Right. However, it's not being considered, and the evidence presented to the inspector doesn't say whether or not it is an issue.
But again, you're not saying to this inspector that this is a really significant problem that we need to take into account and permission should be refused on that basis.
I am happy to say that it is not a primary concern for me, yes.
That's useful. Maybe we'll start every point by doing that then. What's a primary concern and what's not? The criticisms of the plume assessment from paragraph 7.20 of your proof. Shall we turn that up, 7.20?
Sorry, can you say which one again?
Yeah, from 7.20 onwards, really, this is where you are providing your concerns, really, on the modelling that's been undertaken. And what you land at after that, at 7.33, is based on the information presented and made available to me, it is unclear whether the appellant has modelled a reasonable worst-case scenario. Yeah?
Yes.
And I was interested in the language that you used there. It is unclear whether the appellant has modelled a reasonable worst-case scenario, because what you're not doing is advancing a positive case that the study doesn't use a worst-case scenario, just that it's not clear to you that it doesn't. Do you see the point? So, for example, I'm going to put it to you in this way, Mr. Laxon. You don't say to this inspector, this isn't a worst-case scenario that's been modelled. You have some concerns about whether it's worst case.
So I have raised, so yes, I think it's, my evidence says that I have concerns that it's not worst case, that I've raised earlier about the fact the relying solely on the emissions testing to demonstrate the emissions is a concern of mine. And we've talked separately about the potential for a unit-to-unit propagation where if it does happen, then the impacts would be greater.
Okay, well, let's just deal with some of those, because some of the points that you raise are, of course, for professional judgment, and we know that there can be scope for reasonable professional disagreement where that judgment is engaged, yeah?
Yes.
We know, as part of the assessment, that it modelled a fire in the best cabinet closest to the residential receptor, Hillcrest, and the B1365, yeah?
Yes.
That's the right approach. It's to take the cabinet closest to those sensitive receptors and assume that that's the one that's on fire. Agreed?
Yes.
We agree that the study used the maximum 5-second emission from the period in which the plume was monitored.
We agree that they use that period, yes, obviously subject to the concerns around whether that represents a worst case emission.
And that's your timing point, I think, isn't it? But just help me with this. When we're looking at peaks and troughs, I think, did you use that phrase earlier? When we're looking at peaks and troughs in the emissions that are coming out of any BESS fire, an averaging of that will, of course, be somewhere above the trough but below the peak as well, yeah?
Yes, an average would be the middle. It is somewhere in the middle.
The way in which the worst case scenario is going to be the very peak of the emissions observed. Agreed?
In what you're describing, yes, I agree with that.
A worst case scenario would not to be to take, for example, the worst, well, there's a difference between the worst 2-minute emission, where you might get fluctuations, and the worst 5-second. By taking the shortest period of time possible, 5 seconds, you are eliminating the potential that the peak, the very peak, would be diluted by a trough. Agreed?
So yes, I agree with that. If we're assuming that the measurement is wholly measuring the plume and that it's not missing the plume, yes. Yeah. So it depends on what those troughs represent.
And I think what you were saying is that you can see in some of the images that the flame may have swayed over to one side of the monitor or the other. Again, the way to eliminate disparity created by the hood not capturing that is to take as short a time period as possible for the measurement, yeah?
To take a measurement from when you're confident it's in the plume, yes.
And over a short time, because if you've got a moving flame, then the longer you measure in order to take an emissions value, the more likely it is that the flame's going to move around.
So yes, that is more likely. Obviously, you've got two conflicting things here. We've got changes in emissions and intensity, as well as changing in whether the sensor is measuring the plume. So you've got a change in emissions happening and a change in whether or not the plume is present where the sensor is. And it's very difficult to separate those two out based on a fixed point sample.
We can see a visual example of this. I think you already went to Mr. Lester's rebuttal. His figure 1 is on page 3. And it's quite a nice visual representation of what's been taken as the maximum value. So here's page 3, figure 1. And I think as you explained, rebuttal proof of evidence, sorry, madam. And do you have yours in colour as well, madam? Oh,
Sorry, my rebuttal, it's got the... Right, okay, but even so, on the other pages, I've got the header and footer in colour. Ah, yep, I have.
yes, you do. Good. We're all looking at the same thing in glorious Technicolor. That's helpful. So I think as you explained earlier, on the left-hand side, we can see a grey sort of frame with a top view. And it's got the bird's eye view of the 3 cabinets, and we can see where the sensor's located above the middle cabinet, which is the one in which the fire was started, yeah?
That's correct.
And then when it's moved, it's not taken off site completely. What happens is the sensor is moved over. We can see from the grey image on the right-hand side, also with the same top view, that it's moved over to the side of one of the target cabinets, yeah?
That is correct. It's located at ground level below the height of the container.
Now, I think we can all agree that when it was moved to the side of the north target unit, that it would have captured obviously less emissions, wouldn't it? Because it wasn't directly above it capturing the plume.
Less, yes.
But there is some value to be taken from its position there, and we can see this in the graph in respect of the blue line, which is hydrogen fluoride, yeah? Because what we see there is that emissions captured are less, but a trend can still be observed. Do you agree?
Looking at the line on the graph, you can make some observations. What I don't have confidence in is the data itself.
What we can see with the blue line of hydrogen fluoride is that once the sensor is moved, what can be observed is a rapid and continuous decay, which Mr. Lester interprets as fluorine compounds having been largely depleted by the time the sensor was moved. Do you disagree with that as an analysis?
I do disagree with that as analysis, because there's 2 things you can look at here. One, it's very hard to see, but on the red dashed line, the peak when it's been moved is higher than the peak that was assessed. So we've got a change in concentration, but as also we've got a demonstration that the other pollutants below don't show the same pattern of decay. So if you've got if you're in a plume and you're measuring concentrations in a plume, then you'll see the same stuff happening with other typical combustion products. So if they change. And here, I don't think that this is demonstrating the change in emissions from the source. It's confounding it with other interactions, potentially ambient air, being out of the plume. One thing that's worth noting potentially is the noise in the signal, and by noise I mean the ups and downs that are happening lots, are significant to the left of the red dash line, and there is much less noise on the right side, suggesting that the plume there is responding to something different.
Yeah, that's a helpful point that Mr. Lester's just reminded me of, and that's within his proof of evidence. If you take that up and you can actually hold these side by side, it's quite a useful way to understand what was captured and why there was a falling trend for hydrogen fluoride after the sensor was moved when it was. Can you see page 8? You've got figure 1 there, and that demonstrates the same graph for carbon monoxide. Do you see that? So the same sensor, once it's moved, is capturing that pattern for carbon monoxide, but has a very different reading for hydrogen fluoride, yeah?
Yes.
What we can ascertain from that is that those two chemicals are behaving differently as part of this fire. Agreed?
Yes.
And what we are seeing with hydrogen fluoride at the point at which the sensor is moved is a continuous decline in emissions in respect of that particular gas. Agreed?
What we're seeing is that there's a difference between the two different pollutants. My interpretation of the carbon monoxide one shows that it's lower than the peak, i.e. it's outside the plume, so it's no longer in the plume. That it reflects what's happening at what's according to the 0.5 time frame, so very early on, and it's not representing the concentrations within the plume of so we don't know what's happening in the plume at that stage.
The point is that we can see, obviously these are not being captured at a plume analysis any longer because the sensor has been moved to floor level. But what can be observed generally is a trend in the data from that location. Agreed? It's not useless information.
We can observe a trend, yes, I would agree with that.
Okay. And just looking again at both of those graphs, what we see in terms of peak emissions, the 5-second peak emission that was used as part of the plume study, is the highest point on those graphs, yeah? Whether you're looking at carbon monoxide or whether you're looking at hydrogen fluoride. The value that was used for the purposes of the plume assessment was the highest point reached, yeah?
The highest point before the moving of sensor, yes.
Yeah, agreed. But we can see, again, the fluctuation throughout the time it was assessed, and one would expect that sort of fluctuation to continue throughout the lifetime of the fire. Agreed?
Due to the limitations of the sensor measurement, yes, I agree with that.
Not just due to the limitations of the sensor that you've identified, but we would continue to see a fluctuating value for all of the chemicals measured during this fire throughout the lifetime of the fire, yeah?
Correct, as propagation between cell and cell happens and more starts to give off gas, yes, great.
That's the diagram I think you took us to in your evidence in chief, that you will get these peaks and troughs and they will be observed throughout the fire event.
Correct.
And when we look at the plume study, so core document 1.31, so if you go to paragraph 8, we can see here that what the study explains about this is that it's based on worst case assumptions and models the peak fire load representing worst case fire results for the best site. In reality, the peak fire load would last for 1 to 2 hours, and the rest of the fire, another 6 to 8 hours, would be at a low intensity, which would reduce the impact of the fire. The relevant standards that we're concerned with, I think when we're looking at the impact of a fire, is 10 minutes to 8 hours?
That's reasonable, yes.
Yeah. So assuming the highest 5-second measurement is a highly conservative approach, isn't it?
Yes, caveating what I've said before about my belief that it doesn't necessarily represent the highest concentration because of the issues with the sensor. And to expand on that, the published studies which show for HF that there's a range between 20 and 200 milligrams per kilowatt hour, so per watt hour, that's in terms of the amount of energy. That level that's the peak sits at the very bottom end of that range. So it is unlikely to be worst case in that range of published emissions from evidence and studies. So we're saying it is plausible to be at the bottom end of the range.
Yeah. So in a range, and I think Mr. Lester as well has said to you, well, yes, that could be right and they could be higher, but it makes no difference to the overall assessment because what you're looking at is a period of time over which the emissions would be averaged of at least 10 minutes. That's where we get to, isn't it? 10 minutes is the minimum period of time that you're looking at in respect of the standards.
So yes, but what the point I was just trying to make there is that that 5-second peak corresponds to the bottom end of the range of emissions for HF, which go from 20 to 200 milligrams per watt hour. So the peak measurement from the 5 seconds corresponds to something at the bottom end of the full range.
This is your point, I think, at 7.27, isn't it? Which is your calculation is 33 to 49 milligrams per watt hour. And that figure is within the range, as you acknowledge within your proof for the papers that you've cited at 7.26, yeah?
That is correct, yes.
And in fact, interestingly, what we've got is we've got sort of a lower, middle, and an enormous range because the Klassen paper, or Klassen, if that's how it's pronounced, it is a range of 12 to 350, whereas the other two are much more specific in their understanding of where it might lie, yeah?
Yeah, there's different tests that are done for different conditions, yes.
Your point is, okay, well, that's in the range, but if that's been underestimated, then other things might have been underestimated too. And you make a point based on Greenhill solar farm application as part of your evidence.
I do, yes, and I've reviewed Mr. Lester's rebuttal regarding analysis of that, and I'm content to agree that it's not necessarily a useful contributor to this, even though it's been based on, it could be a miscalculation from their work rather than anything else, potentially. However, the approach that's been done by them is to back calculate the concentration at the measurement location. And that demonstrates that the concentration, if it is permanently in the plume, if the sensor is permanently in the plume, it demonstrates that there is that variability, and by missing the sensor and the plume analysis, you're missing concentrations because it's back calculated to be so high.
It's right, isn't it? I think the modelling in that case used did it use the emissions from the modelling that we've got in this case?
I believe so, yes.
And that's at examination now.
Again, as far as I understand, yes.
I can see why you try to depart from that case now, given that it used the modelling that's available to this inspector, or rather the emissions rates from the modelling carried out by Wardzilla. It used the Gaussian model in that case. But just to be clear, the Gaussian model is not designed to give robust pollutant concentrations over very short distances, is it?
It typically represents the conditions which you put in for the inputs, as most things do, and in most cases that input is a 1 hour average condition. It doesn't, there are ways to consider in fluctuations within the hour as well. But yes, it is reasonable to represent a 1 hour average concentration.
Yeah, I was on spatial, you've gone to time. Can we just go back to my question? And that's that the Gaussian model is not designed to give robust pollutant concentrations over very short distances.
I agree that, as I said earlier, that my opinion is CFD is very good at doing, still has limitations, very good at doing the first 10 to 20 meters, and that Gaussian plume models are very good at beyond that distance, so the 10s, the 20s, and plus up to about 200, including 200 meters away.
I'm really interested in where you draw the line, because are you saying that at 20 meters, CFD modeling just breaks down completely? Is that your case?
The limitations of CFD modelling is that it doesn't account for the various different atmospheric conditions, which start to dominate the behaviour of the plume the further away you go. So there are, the limitations are less within the near field than they are more than 25, 30 metres, where the plume starts to behave like a parameterised plume, which is what a Gaussian plume model does. It parameterizes it.
Yeah, so, and I think that just explains, you didn't answer my question. I think you did it in a roundabout way, because my question to you was, are you saying that CFD modelling breaks down at 20 metres, that it hits a wall and that's it, the whole model destabilises? As I understand it, that's not what you're saying, because you've said it's got limitations. You've gone to 25 to 30 metres, fine. There are differences between the models and the distances over which they best perform. But we can agree, can't we, that CFD modelling doesn't hit 20 metres and break down completely?
Yes.
Probably a useful place to stop for lunch, madam.
Okay, thank you very much. We will now break for lunch and we will reconvene at 2 o'clock. Before we do break, do you have a feeling for how much longer your cross-examination?
Half an hour.
Thank you very much. Okay, if there's nothing else, we will adjourn until 2 o'clock.